What's up, Algebra 2? I'm so sorry, but I will not be in today. I'm going to get my eyes checked on just to make sure that everything's okay. So we are finishing up those Desmos notes. We started going through the past couple of days the graphing rational functions. So what you're going to want to do is open up 7.2, graphing rational functions. Those notes, the Desmos activity. You'll also see that there is a YouTube video attached. This is the video I'm making right now, so you can follow along the video and follow along through that Desmos activity. These are taken right from those slides. And sometimes we will be doing problems together. Sometimes I will ask you to pause the video, and when you pause the video, you'll do a couple practice problems. So sorry I'm not there. You guys know I wish I was there. I do need to go just get my eyes checked out, make sure nothing's wrong, and I will then see you guys on Monday. All right, so pull up that rational functions notes, get ready to go, have the Desmos open, have my video playing, and we got this. All right, so in the top right corner, you'll notice it tells you which slide we're on in Desmos. So cruise on over to Desmos slide 10. We are going to continue graphing rational functions, only now you'll notice that our rational functions will be in the form of y equals ax plus b all over cx plus d. Okay, this is just called standard form of rational function. The other form, that AH and K form, that was our transformation form. So the question is, how are we going to graph a rational function when they're in this form with this ax plus b on top and this cx plus d on the bottom? Because we no longer have an AH and K value. So we can't tell just by looking at this where our origin moves to, or in other words, where our vertical and horizontal asymptotes are. So couple things to note. All rational functions of the form y equals ax plus b over cx plus d also have graphs that are hyperbolas. Even though these look a lot different, it's still that same idea. So how are we going to find our vertical asymptote, and how are we going to find our horizontal asymptote? So that's the big thing, because until we have our vertical asymptote and our horizontal asymptote, we're not going to be able to graph this hyperbola without using another graphing software. So the vertical asymptote is the line x equals negative d over c. I do not love this, but this means because the function is undefined when the denominator cx plus d equals 0. To find the vertical asymptote, all you're going to do is set the denominator equal to 0. So I'm going to just write a note. This whole bullet point, the vertical asymptote of the graph, yes, it is x equals negative d over c, but the reason it's negative d over c is we're just setting the denominator equal to 0 and solving. So I'm going to make that note. So let's make a little star. Set denominator equal to 0. So if we were to take cx plus d, the denominator, and set it equal to 0 and solve for x, we would subtract over the d. So we would have cx equals negative d, and we divide by c. So x equals negative d over c. So that's where that comes from. Just know you're just setting the denominator equal to 0 and solving for x. That's how you're going to find your vertical asymptote. It's kind of like we're finding our h value. Horizontal asymptote is a little bit different. So the horizontal asymptote, let me get this highlighter ready, is the line y equals a over c. So a and c are the coefficients of x. So to figure out, hey, where is my horizontal asymptote, you just take whatever number's in front of your x on the top, divide it by whatever is in coefficient is in front of your x on the bottom. So for example, if a was 2 and c was 1, we'd just take 2 divided by 1, and that would be our horizontal asymptote, y equals a over c. So I added this little red box just because I wanted to simplify all this word. So for vertical asymptote, I didn't want that color. So vertical asymptote, we would just set the denominator, set equal to 0. This would be your vertical asymptote. To find your horizontal asymptote, you would just do A divided by C. That would be your horizontal asymptote. You can plot both your vertical and horizontal, and then you can sketch your parabola. Or not parabola, sorry, hyperbola. Okay, so this was slide 10. We are going to just move on to slide number 11. Okay, so your slide number 11 should look like this. We have the function f of x equals 2x plus 1 all over x minus 3. Again, we are going to want to state the domain and range, and we're going to sketch a little bit, a nice graph of this. Okay, so first off, we need to figure out what our vertical and horizontal asymptotes. Remember, for our vertical asymptotes, we're just going to set the denominator equal to 0. So I'm going to set x minus 3 equal to 0 and solve for x. So, you know, we should be able to do this pretty easy. X minus 3 equals 0. Adding 3 to both sides, we get x equals 3. So this is our vertical asymptote. X equals 3. So vertical asymptotes are going up and down. So I'm going to go over to x equals 3. I'm going to grab my fancy dotted line. I'm going to make it a red. I'm going to go over to x equals 3 and draw my vertical asymptote. So there's my vertical asymptote at x equals 3. Whoa, I want to grab that line. I'm a perfectionist. Well, it's not going to be perfect. Okay, vertical asymptote. X equals 3, set the denominator equal to 0. Easy peasy lemon squeezy. Okay, horizontal asymptote. I'm looking at the coefficients in front of x. Okay, so for our horizontal asymptote, I'm going to have y equals a over c. Okay, my a value, let's highlight it, is 2. My c value is this number in front of x, which is an invisible 1. So my horizontal asymptote is going to be at 2 over 1, which is just y equals 2. Horizontal asymptote. Nice. So again, we're just going to go over to our graph, and we're going to graph the line y equals 2, which is our horizontal, so it should be flat. Let's pull back out my fancy dotted lines and create a dotted line at 2. 1, 2. Draw that bad boy across. So here are my new asymptotes. So you can see this graph moved over to the right 3, and it went up 2. There's where that new origin is. And now all we need to do is we need to graph the hyperbola. So the question is, before we knew that our, based on our a value, if it would start top left or top bottom. So the question is that still apply? So if I were to type this into Desmos, let's take a look. X minus 3, typing it in. If I did type this into Desmos, you can see we still have this hyperbola, and you can see we're starting bottom left. And actually the same thing applies. If I were to make the top coefficient in front of x negative, it does still flip the graph. So here, since the top has a positive a value in front of our x, then that means our graph is still going to start bottom left and go to top right. So from here, remember, I'm not too worried about you drawing perfectly, so all you need to do is sketch your hyperbola. Let's see how I do. Pretty good. And then go into top right. There's the sketch of my hyperbola. Of course, now we still need to do our domain and range. Our domain and range are based on our asymptote. So we know that we have a vertical asymptote at x equals 3. So our domain is all real numbers, except x cannot equal 3, because we approach 3 on the x, but we never touch it. Horizontal asymptote helps us determine our range. Again, we always know it's all real numbers. However, we are approaching this line y equals 2. So we know y cannot ever be 2. And there we go. We graphed a hyperbola that's in the standard form. So, quick rundown of just kind of what we did here. We found our asymptotes by setting the denominator equal to 0 for our vertical asymptotes and dividing the numbers in front of our x, our coefficients, to find our horizontal. Once we have those, we plot our 2 lines and we sketch our hyperbola. We know it started bottom left because the 2x plus 1, the 2 was positive. And then we found our domain and range, making sure to exclude x and y based on our vertical and horizontal asymptote. Okay, so pause the video. Pause it. Do slides 12, 13, 14, which are 3 practice problems just like this, okay? Graph it, find your vertical, horizontal asymptotes, state the domain and range. When you're done, go ahead and continue the video. All right. You unpause, which means you're done with 12, 13, and 14. Don't lie to me, I'll know. Okay, so you're done with 12, 13, and 14. We are going to slide 15, which is taking a hyperbola, a rational function that is in the standard form, and we are going to convert it to our transformation form, our a over x minus h plus k. Okay, there's a couple ways we could do this. One way we could do this is we could try to simplify this. However, the easiest way to do this is we are going to have to think back to the good old days, and we are going to use long division to divide these two. Okay, so in order to convert this into the form a over x minus h plus k, which is that transformation form, we're going to have to do division. Since this is a rational function, it's 2x plus 3 over x plus 1, which literally means we're taking 2x plus 3 and we're dividing by x plus 1. So we can actually do that long division. So let's do some long division. I'm going to draw my little bar. On the inside, I have 2x plus 3. On the outside, I have my x plus 1. Okay, so remember division. Just like long division, we're asking ourselves, how many times will x plus 1 go into 2x plus 3? So I always think about, okay, what can I multiply x by to make it match this first term? So I can multiply x by 2 to make it 2x. So I'm going to draw my 2 up on top, and then I'm going to multiply. 2 times x plus 1. 2 times x gives me 2x. 2 times 1 gives me 2. Okay? When I multiply, now I'm going to subtract down like we would during normal long division. So I have 2x minus 2x is 0. And I have 3 minus 2, which gives me 1. Okay? So that's my remainder. So when I divide 2x plus 3 by x plus 1, I'm left with a remainder of 1. Okay? So now to rewrite this, we're ready to rewrite it as a over x minus h plus k. So how would we rewrite this? Let's take a look. So we know we have a remainder of 1. So we know we're left with 1 over x plus 1, that's our remainder. Remember, when we have a remainder, we take a remainder and divide it by what we're dividing by. So 1 over x plus 1, and look, that looks a lot like a over x minus h. And then we know that we could easily fit 2x plus 1s into 2x plus 3, so we add that 2 on to the end. And now we have a rational function that's in the form of a over x minus h plus k. So just let me highlight with some colors so that you can see. So this 1 over x minus h, here's where that 1 came from. On the bottom, we divided by x plus 1 because we were left with a 1. We're left with 1 over x plus 1 because we can't divide those. And then our 2 came from the top because we knew we could fit in 2x plus 1. Okay, so now I'm at the point where I have a, h, and k, so we can graph this just like we were graphing earlier this week. So my h value, let's do it in blue. I guess I should do it in green, shouldn't I? if I'm being smart. So my h value comes from here. Since it's a positive 1, h is negative 1. My k value, which I have highlighted blue, is positive 2. So I have my negative 1, positive 2. Let's sketch those lines. How are you guys feeling with, we got to do some division, don't we? Haven't done that in a while, and I wasn't the one who taught you it, so you guys will have to send me emails, send me reminds if you are struggling with dividing so that we can help you out. Okay, let's draw my horizontal or vertical asymptote down at negative 1, and then my other asymptote at y equals 2. Again, these are my two asymptotes. When we do transform, you can always think, okay, so this is the point negative 1, 2. So instead of my asymptotes going through 0, 0, I've just moved to the left 1 and up 2. And here's my new origin. Here's my new asymptotes. My a value is positive, so I know I'm going to start bottom left and go top right. So take out your... Oh, too bad. If you're in person, you don't get to use the fancy sticky notes. Oh, I feel bad now. And there we go. There's the sketch of our hyperbola. Okay, so this is converting from standard form to transformation form, and we do it using division. So since rational functions are just division, 2x plus 3 divided by x plus 1, we actually divide 2x plus 3 divided by x plus 1. We knew it went in 2 times, but we had a remainder of 1. So we rewrote as 1 over x plus 1 plus 2, which converted it into that transformation form. We knew what our h and k was, so we know where our new origin is. And that new origin was at the point negative 1, 2. Draw your asymptotes, and then sketch your parabola based on whether this is positive or negative. And we're done. Graphing rational functions. So, here's what you have for me. Complete slides 16 and 17. Your day has come to an end when you finish those two. And then have a great weekend. I will see you guys next week. And I think next week there's ACT or SAT testing for juniors. So, we'll have to kind of take that and see what we're going to do that day and see how many people that are going to be missing. All right, guys. Have a good one. Email me if you have questions. Or send me a remind.